Here is another example. So step 1, find the longest carbon chain. Don't leave this guy out. We have a 6 carbon chain. There's a double bond, so it's a hexene. Double bond is on carbon number 3, so it's a 3-hexene or a hex-3-ene oic acid. We have methyl groups on carbons 3 and 4, so it's a 3,4-dimethyl. And this double bond is on Z same side. So this is a 3Z, 3,4-dimethyl. And then you can either put the 3 out in front, 3-hexenoic acid, or you can put the 3 in the middle, hex 3-enoic acid. Sometimes it's easier to put it in front, sometimes it's easier to put it in the middle. Next example, let's do an aromatic, a benzoic acid. Since we've already done quite a bit of naming for these, this shouldn't be too tricky. Again, because the carboxyl group is the highest priority functional group, this is going to be carbon number 1. And then you number around the ring to give the other substituents the lowest possible numbers. So for this we have nitro groups on carbons 2 and 3. It's a 2,3-dinitro benzoic acid. Here's another cyclic. We could take the easy route and call this trans, but I always think it's good to practice our R's and S's. So here we have a cyclic, 6-numbered ring, cyclohexane carboxylic acid is what we would call it, the parent name. There's a methyl group on carbon number 2, so it's a 2-methyl cyclohexane carboxylic acid. And we have stereochemistry on carbons 1 and 2, which we'll assign in just a second. Notice that in the IUPAC system, the E doesn't get dropped when you're naming a cyclic carboxylic acid, only with the straight chains. So that it's not cyclohexane, ANCAR, it's got the E's included. So let's figure out the stereochemistry for carbon number 1. High priority group is sticking out, the hydrogen in the back is low. This would be 1, 2, 3, so that's an R. And on carbon number 2, looks like the low priority group is out in front, the hydrogen. So we'll assign stereochemistry the way that it appears and then reverse it. Looks like this is our number 1, this would be number 2, and this would be number 3. So this looks like an S, but because hydrogen is in front, it's actually an R. Let's do another. This example is kind of tricky. This one's kind of tricky because you see that benzene ring and you look at that as being the longest carbon chain, but keep in mind that the carboxylic acid group is the highest priority group. So this has got to be carbon number 1. No matter what else is going on in the molecule, that carbon is always carbon number 1. And here's carbon number 2, and that's the chain, a 2-carbon chain with a benzene ring or a phenyl ring on carbon number 2. So this is a 2-phenyl. There's 2 ways that you can name it. You can either use its common name, acetic acid, or you can use its IUPAC name, which would be ethanoic acid. 2-phenyl ethanoic acid. That would be IUPAC. Or 2-phenyl acetic acid. And actually, if you're going to go common name with acetic acid, you probably don't even need to have that 2 there, because the only place that the phenyl group could be is on carbon number 2. There's no room for it on carbon 1. So you could get away with calling it phenylacetic acid, and people would be able to draw a structure from that name. If you have 2 carboxyl groups on a molecule, the molecule is a dicarboxylic acid. And of course, you could have more than 2 carboxyl groups on a molecule, but we're only going to worry about naming ones that have 2. If the 2 carboxyl groups are on a benzene ring, let's say you got one, and then you have another one somewhere else. This notation right here, which hasn't been introduced yet in class, with the aromatic compound and a bond going right into the center of the ring. Notice that it's not attaching to any carbon at all. That means that this second functional group is somewhere on the ring. It could be, these 2 groups could be 1, 2, they could be 1, 3, they could be 1, 4. Don't know where it's at. So that's what that notation means. If you have 2 carboxyl groups on a benzene ring, the molecule is called a phthalic acid. That's its common name. And you would just indicate the position of the 2 carboxyl groups using the ortho-meta-para notation, or 1, 2, 1, 3, or 1, 4. So this molecule here would be called an orthophthalic acid. Or you could call it a 1, 2 phthalic acid if you wanted. If you have a straight chain dicarboxylic acid, you're going to name this molecule as an alkane dioic acid. Notice that the E is retained. I believe that we retain the E's in the diols as well, so it's not totally unusual, but that E stays put, doesn't get dropped off like in a regular carboxylic acid. To name a straight chain dicarboxylic acid, your strategy is to find the longest carbon chain that contains both of the carboxyl groups. So you're going to count from one carboxyl group to the other. They have to be at the ends of the chains. You can't have a carboxyl group in the middle of a chain. It doesn't work that way. So you're going to find the longest carbon chain with both carboxyl groups, one on each end. And you're going to number from one carboxyl group to the other to give the lowest set of numbers to the other substituents that happen to be on the molecule. And if there aren't any, then it doesn't matter how you number it. Number to give lowest numbers to the other substituents. For example, with this molecule, dicarboxylic acid, we are going to number from one carboxyl group to the other, giving the methyl group the lowest possible number. Now, don't start counting here, start counting here. Don't forget to count the carbons of the carboxyl groups as well. 6 carbon chain with a methyl group on carbon number 3. So it's a 3-methyl hexane dioic acid.